Hey, fellow mathers, thanks for listening to the podcast. Before we get into this episode, have we got some really important information?
Y'all, registration is now open for our Building Powerful Mathematics online workshops. These are the magic, the why, when, how, the details, the experience, making real mathing happen in you and your classroom.
We've got a workshop targeted for your grade level. Whether you teach kindergarten, high school, or anything in between, you can find the best workshop for you at mathisfigureoutable.com/workshops. mathisfigureoutable.com/workshops.
Registration is only open for a short time, so book your spot before it's too late. Now on to the show.
Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
We know that algorithms are amazing historic achievements, but they are not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable.
Hi, Pam.
Right. I'm getting that down, I think. Finally, the new intros. Finally, kind of.
Is it still new? I don't know. It's been a month.
I mean, just
and
a few. It's just a few episodes. It's only fine. Yeah. Hey, Kim.
Hi. So we're excited. We're just coming off a challenge, which
Woo!
is super fun, right? It's
super energizing,
intense, but it's good. And there's always so much learning, which is cool. And
so
of course,
many people from around the world.
Yeah, and lots
really
of first-time people, which was so fun.
Yeah.
And in it, of course, we did some problem strings, which is
of course
your favorite and
my favorite. Mm-hmm.
So I wanted to share that Judith Griscom said she was a fraction workshop participant, and I'm mentioning her because she was also in the challenge. And she said, I privately tutor an upper level math student who has been mimicking teacher procedures her entire math life. I mean, many are, right? She said, I've started to do little things like problem talks with her where we look at one or two particular problems, stew in them for a bit, and talk about efficient ways to approach each one. It's been eye-opening for sure. So I bring this up because we talked a little bit about problem strings and problem talks in the challenge. But then she said, kind of related, but I finally listened to the math strat chat for this week on the podcast, and it was 144 minus 36. I don't know if it was this week, but anyway, she said, I know, it was in fractions, but she wanted to share her thoughts with us. And she said, for the first time, I saw this as a multiplicative problem, meaning she saw it as 12 times 12 minus 4 times 12.
Oh.
And she said, it's taken me hearing this on the podcast probably 3 or 4 times to finally have it be something I see on my own. And it just reinforces the idea that you can't give up on kids if they don't get it the first time. Even as a math person, it took me a few times to get it to click. And so I loved that for all the reasons.
Yeah.
But you know what? I love that she said it took me a few times, which like, that's kind of why we do series of problems in Math Strat Chat, right? Nobody, if anyone thinks, hey, I'm going to see something one time and I'm going to like get it, I'm air quoting, get it. That could put some pressure on you that, you know, there's something wrong with you if you don't see what people are seeing the first time.
Totally. Yep.
And, you know, it's just, it supports what we love about problem strings. And she mentioned the podcast. So.
Well, it supports what we know about learning. Let's be clear. Maybe you can rote memorize something and be able to retrieve it again, but to actually learn something down deep, that takes your brain traveling that path a few times, and then not just having it be like one solitary lonely path, but with connections. Yeah. It's like it's more of a map of the terrain and not just like this one path. Like owning something I don't know if it's ever a one-time thing. So I think really learning. Absolutely. Way to go. Thank you for sharing that. That's nice.
Yeah. And it was kind of fun because you actually did a problem string a little bit towards this in the challenge as well. And it's like we like doing a series of problems. Okay. So today we're going to kick off a short series that people have been asking for. And we do love getting suggestions from people. So you can always email me if you are dying to hear something on the podcast. That's Kim@mathisfigureoutable.com.
Yeah, totally. Email Kim, not me.
It won't get anywhere.
I mean, I'll probably read it. It's just, I'm so terrible at answering. That's the problem. Yeah, all the things.
Yeah.
I try.
So today we're going to chat about fraction multiplication.
Ooh,
yeah. And you actually had some fun with that recently.
Yeah, totally. So one of the things that we do for our online community called Journey is that we video problem strings in classrooms with kids. I was going to say real kids, and then I knew you were going to laugh at me. Not fake kids, real kids in real classrooms with real teachers. And then you and I voice over them so that teachers can hear our reflection about what's going on and everything. And so we recently filmed in an 8th grade class. Shout out to Wallace Middle School and Miss Castro. We had a fantastic time there. What a great group of kids. So it was 8th grade. I had a blast. And in one of the class periods, I did this particular problem string. So Kim, what I'm going to do today, maybe a little different than we've done on the podcast, is I'm going to say a problem. And instead of asking you how you would solve it yet, I do want you to think about it. So I want you to kind of get in your head how you would think about it. Then I'm going to kind of tell you the experience that I had in the class, and then we'll come back and ask you how you think about it. Is that okay?
Okay. Yeah.
Okay, cool. So in this particular class, I had done, when we film, I usually go in the day before. You taught me this, actually. I go in the day before so I can kind of get to know the kids a little bit. They get to know me a little bit. We put their names on name tents so I can pronounce them correctly, because I'm sure we've said this on the podcast. I think names are important. We think it's important for kids to hear their name and, like be seen. Anyway, so I had been in the day before. This group was a great group. They were a little energetic, I'll say. Yeah, and it's right before lunch. So, and they ate lunch late. So they were like hungry. It was funny because a couple of them were coming in like stuffing snacks in. The teacher was like, the teacher was like, when the bell rings, you got to put those away. And so they were like, rah, getting them in. It was great. You can see they had this great rapport with her because they're smiling at her with their cheeks all out, it was great. Okay, so I started the problem string and I just wrote on the board 1/4 times 1/5, but I said, what is 1/4 of 1/5? And then I kind of paused a little bit and I said, all right, you guys go ahead and I looked to see if there would be like this instant, oh yeah, but and no, there was not an instant. There was kind of like this thoughtful look on some of the kids' faces. On some of the kids' faces, it was a little bit more of a panicked look. Now let's be clear. It's 8th grade, right? So this is not their content. This is not something they do. It's not something they were responsible for this year. It's probably something they haven't necessarily seen very much for a while. And a couple of the kids kind of looked at each other and I thought, okay, we're going to need a minute on this. And so I said, all right, think about it. Turn to the person next to you. What are you thinking about 1/4 times 1/5 or 1/4 of 1/5? So I walked out into the group and I'm listening to just a few students. A couple of kids were talking and based on what they were talking about, I kind of drew this rectangle on the paper and I said, so if this is a candy bar, what are you talking about? And they sort of talked about what 1/5 of the candy bar would look like. And as I was talking to this group, there's 2 partnerships were kind of getting in on it. The coach at the school, he was also in the classroom. And there was everybody was talking, right? Because I said, turn and talk to your partner. And he kind of laughs loud enough. And I look up over at him and he's like, you have got to hear this. And I said, like, what's going on? So I kind of walked over there and he goes, this is like proving everything you've been saying. And I said, say more about that. And he goes, these group of kids over here are arguing between these 3 algorithms. And I was like, what do you mean? And he said, they're trying to decide if they are supposed to cross multiply and divide. Or if they're supposed to, God, what were the other 2? Cross multiply and divide. I can't even remember. But none of the 3. So what would they be? Invert and multiply. That was one of them. Cross multiply and divide. They called it keep, change, flip. I can't remember the third one. But the 3, none of them were multiply cross, which is sort of like the rule if you were going to memorize a rule for multiplying fractions. And so he was cracking up. He's like, they're over here arguing between these 3 and they're pretty sure it's one of these 3 and it's not even the right one. And he and I just kind of smiled a little bit. So then I walked up to the front of the room and I said, hey, this group over here, they were kind of talking about a candy bar. We were talking about sharing. And so can you guys just start us off? And so that group said, well, if you had a candy bar, so then I drew on the board a big, long rectangle. So it's a long, flat, not tall, but like a wide, it's a horizontally long rectangle.
Hey, Pam, should I be drawing? I'm thinking
maybe. We're thinking back to recent experience where we were totally got lost in each other's visuals. Yeah. Maybe that's why I was like describing this rectangle so much.
I'm making a long rectangle.
So it's like horizontal, right?
It's
like fat. Okay. It's not tall. All right. So this is a very long, like Hershey bar kind of rectangle.
Yep, I got you.
And I said, so if we want a fourth of a fifth, what is a fifth of a candy bar? What does that look like? 1/5 of a candy bar. And that wasn't too bad. Though there were definitely some kids that were still it was almost shell shocked was the look. Like, please don't ask me about fractions. And I said something like, all right, 1/5, what is it? And somebody said, well, draw 4 lines, which I thought was super interesting because this kid's thought about drawing things and into fifths or into pieces, because typically a very first answer for a kid might be draw 5 lines, right? Fifths, draw 5 lines. But if you draw 5 lines, then you've cut it into 6 pieces. If you haven't tried that, listeners, you might want to try that real quick. Like, how many lines do you draw in order to separate something into pieces? So the kid said draw 4 lines, and somebody else was like, no, not a fourth, a fifth. And I was like grinning a little bit. And I was like, okay, so like, what does 1/5 mean? And some kid said, well, it's like 1 out of 5. He didn't say equal pieces, but something that meant that, like 1 out of 5. If you're sharing with there's 5 of us sharing. And I was like, okay, so let's draw that up here. And I kind of cut it in. And hey, cutting something into 5 pieces is not easy, right? 5 equal pieces. Because you can't like cut it in half and then cut it again. I don't know. You have to kind of eyeball 5 equal pieces. Anyway, so I kind of eyeballed 5 equal pieces. I said, is that good enough? One kid goes, make that line go over a little bit. I'm like, okay. So I, kind of
nice.
Yeah, I know. So we sort of shifted a little bit. And then I just drew 1/5 right above one of the pieces. In hindsight, I almost wonder if I wish I would have put 1/5 above all 5 of the pieces, like 1/5, 1/5, 1/5, but I didn't. I just put 1/5 above the first kind of leftish piece. And I said, all right, does everybody agree this is like 1/5 of the candy bar? If we had a candy bar and we cut it into 5 equal pieces, each of us have got a piece. And what would that piece be called? And they were all like, okay, 1/5. I'm like, oh, we got that. But the problem was we want 1/4 of that fifth. Again, kind of this shell-shocked look, like, don't ask us to do stuff with the fractions. And or for sure don't ask us to like understand stuff with fractions, which was equally interesting. So I said, let's go back to that sharing thing. Like, here we've got this, it's almost like we've got this piece here, this 1/5, and that's what we're focused on. But now more people came in, and now I don't get that whole 1/5. Now it's like, I got to share it with some more people. Like, how many more people? And that we had a little conversation about that. Like, is it 4 more people and me? Or is it me and 3 more people? Okay, so all right, there's 4 of us. There's 4 of us that are going to share this piece right here. And I'm like, what do you want me to do? And so we cut that fifth vertically into 4 pieces. And that was a little easier to do. We took that little 1/5 and we cut it in half. And then we cut those halves in half. And so we had 4 equal pieces of that 1/5. Does that make sense? Right, Kim. So I kind of want you to tell me what your rectangle looks like right now.
Yeah. Okay. So I have the long rectangle, the original Hershey's bar. And I have cut it into those 5 really not equal pieces.
They should be though, right?
It should be. It should be. And I did go ahead and label above each of those chunks 1/5, 1/5, 1/5, 1/5, 1/5.
Okay.
And so then I kind of zoomed in on the left 1/5, and I kind of ignored the other first side. But on that left 1/5, then I drew 3 lines.
And which direction?
Like columns. So I drew them vertically.
So in that moment, the coach and the teacher in the back of the room, if I remember correctly, both of them looked at me like I was off. And I don't remember who, but I think one of them said something about, why didn't you draw those lines horizontally? We're going to talk about that in a second. So that was kind of an initial reaction. It was like, why are you breaking it in kind of the same way I had broken the fifths? It's almost like I was snapping the candy bar into fifths. And how we're here, we have this 1/5. And then I snapped that 1/5 kind of the same way into 4 equal pieces. And so now we have those fourths. And then I said, okay, guys, so here is a piece. And I shaded in that far left little guy, that little 1/4 of that 1/5. And I said, here is this little piece. This is the one we're talking about. This is 1/4 of 1/5. What is it called? Kim, I got to tell you, in that moment, I fully expected everyone in the class to go, oh, okay, it's 1/20. Like I just had this, I was like, now that we're clear what it looks like and it's right there, then everyone's going to be like, oh, duh. Okay. Nothing. Now, the kid that said draw 4 lines, that kid was smiling. That kid was like, yeah, I got it. maybe there were a couple of other kids that were like, okay, but for the most part, most of them were like, what? And I mean, not in a bad way, right? But like in an honest, like, I don't know, like, how could we know that? And so we kind of went back a little bit and we chatted a little bit about why did we call these 1/5? Oh, because they were 5 equal pieces. Why did we call these 1/4? Because they were 4 equal shares of this little piece. And so what is this? What is this one out of? This is an equal piece out of. And one of the kids said something about, well, if you cut all of those 1/5, which is, Kim, why I kind of had wished maybe I'd labeled all of the 1/5.
Mm-hmm.
So if you cut each of the 1/5 into those 4 equal pieces, if you cut it all, so the whole candy bar, we've now snapped each of those fifths into 4 pieces. If we cut them, then how many of those little tiny snappy pieces would there be? And then a kid was like, oh, I think there'd be like a lot of them. And I was like, right, good. How many? And they're like, and then a kid literally started adding. We'd have 4 and 4 and 4. And I'm like, okay, you're thinking additively. Got it. I don't know if anybody was counting them all, though I wouldn't be surprised if they were counting. So we could have had counting strategies. We definitely had additive where they were like, okay, there's 4 pieces in that fifth and 4 pieces in that fifth. And then we definitely had a few kids that were like, well, there's 5 1/5 and each of them has 4 pieces. So there'd be 20 total pieces. Yeah. And I was like, oh, okay. So if there's 20 total pieces, so then right next to the problem, 1/4 times 1/5, I had written that on the board. I wrote equals. You said there's 20 total pieces. I drew the fraction bar and I put the 20 underneath. And I said, so there's 20 total pieces. How many pieces are we talking about right here? And they were like, oh, one of them. And I said, okay, so that's 1/20. It's 1 out of those 20 pieces. Kim, I swear, most of the kids in that class were like, yes, okay, yes. It's like they were reasoning maybe for the first time or at least for a long time. Yes, that makes sense. Yes, 1/20.
Yeah.
All right.
Okay. So like there's so much to unpack here. And I don't even know where you want to go next. But when you said, oh man, so I can feel this pull that you're, and not in a bad way pull, but like you're bringing kids into this, we're thinking big candy bar. Then I'm helping you zoom in on a fifth. Then we're diving deeper into zooming on a fourth of a fifth. And then we're zooming you back out. And that is the reunitizing that, of course, we would expect kids to be like, wait, what? That shift in thinking is shortcutted. Shortcutted, is that a word? We shortcut that shift in thinking by saying, oh, just multiply across. It makes no sense to them because they haven't experienced what you just did with them. And changing what they're focusing on is a necessary part of really understanding where are those 4 pieces within a fifth that then make it be 20 total pieces.
Nicely said. Yeah. And so AVR people, I think, would call that coordinating units. It's like how many different levels of units. You said reunitizing. So we sort of have a candy bar. That's a unit. And we cut it into 5 equal pieces. So now we've got 5 units, right? Well, first we have 5 units, and then we can now zoom in, like you said, on one of those, and that's 1 out of those 5 equal shares. So then now 1 out of those 5 gets its own name, 1/5. And now we zoom in again, and we cut that 1/5, just that one piece, into 4 equal pieces. So now we've got 4, but we only drew 3 lines. And we cut it into 4 equal pieces. And so now we've got 4 equal pieces. And now we have a new name for those. Now a new unit of each of those is 1/4. That's a new unit. And then brilliantly said, we have to zoom back out to talk about how many total of those little guys would be if we'd cut it all up that same way. And now we've got the number 20 of those little pieces, but then it's only 1 out of those 20. So now those little pieces have a new name. There's 20 of them, but there's 1/20th of that whole candy bar.
And can we also acknowledge that we haven't even talked about one thing, that when we say 1/4 of a fifth, kids are used to drawing, like if we have a 3x5 array, we're used to telling them that means 3 groups of 5. Think about the 3 first. When we say 1/4 of a fifth, we're suggesting that you focus on the fifth first and then operate on that fifth.
Oh, that's very nice. Yeah. Yeah. Let me do that with an example. Like if we had 3 times 4, we think about 3 groups, and then you can think about of 4 things. right? 3 groups of those 4 things. So you're thinking about the 3, and then you can picture in each group those 4 things.
And if
But
you're representing on an area model, you draw, I mean,
3,
I'm not,
yeah,
3 down.
yep, three rows by 3 columns. Yeah, so you're totally thinking about the 3 rows first by the 4 columns. Nice. And in this case, we're saying, hey, to think about a fourth of a fifth, you got to find that fifth so that you can think about 1/4 of it.
Yeah.
And that's, yeah. And then let me add one more layer of unitizing on that. So it's 1/4 of 1/5 of the whole unit. Like it's 1/4 of 1/5 of the candy bar. So lots of units, lots of reunitizing. Kim, when you said there's so much to unpack here, you know what was screaming in my head was the teacher, the honest, well-meaning teacher right now, who, thank you for still listening, who's like, oh my gosh, you guys are making this so complicated. Why don't you just tell them, multiply the numerators, multiply the denominators, and you're done? Why are you making it so hard for kids? You're being mean. Like this is, and you're wasting your time, and you're causing unnecessary struggle. When they talk about productive struggle, this is exactly the wrong thing that you want to do in your class, because now the kids are all, if you are thinking that, if you have colleagues who think that, I respect the fact that your instinct right now is to go, whoa, that is really confusing. And it doesn't need to be. For these kids to get answers, all they have to do really is just multiply across. Correct. If all we want is for kids to just get answers to this problem, all they have to do is multiply straight across. But if we want to build their brains to think and reason proportionally and multiplicatively about fractions, then I'm going to suggest that we cannot just tell them to multiply straight across. Or what we'll get is what those groups were doing when I threw out the question.
Yeah.
Like when I threw out this question and they were honestly like sure that it was one of 3 rules and none of them were multiply straight across. That's what we get when all we say is, let's just do the easy way. Let's not make kids struggle. Y'all, we don't ever want kids to unproductively struggle. We're not asking for struggle just for struggle's sake. What we're asking for is for kids to honestly grapple with the math, the mathematics, the relationships at hand, making sense of it so that they can continue to reason and make sense of math.
Yeah.
Okay. Go ahead.
Well, I was just going to say, I think many of us acknowledge that when we do what we've traditionally done and say, here are some rules, memorize those things, there are some kids who can hang on to it a little bit. And then there are some who have not traditionally been able to do that. And if we keep doing that, we keep saying, just memorize these rules, we're automatically discounting certain kids. We're saying this is too hard, or you can't hang, and so sorry for you.
But we really mean you can't rote, memorize, and mimic.
Yeah, and that just like that feels to me like we're automatically saying, well, I know some kids are going to have a difficult time with this because they have for years and years and years and generations, but
it's so much easier for the other kids that let's just go with that. And I get it. Like if math is about rote memorizing and mimicking, then yeah, you would want to do that the easiest way possible. We're asking everybody to consider, what if it's not? And we're suggesting that it's actually not. All right. So Kim, I asked you when I said 1/4 of a fifth that I was going to kind of thank you for letting me walk through kind of what I would do, what I did with these kids. How would you, if I just had said, hey, Kim, what's a fourth of 1/4 times 1/5? What would you have done mentally?
I think I've had enough experience that I don't necessarily picture a candy bar, but I can lean back on that and say, I know a fifth. I know that I'm focusing on a fifth first. And I know that if I don't know, I guess I know if I have a fourth of it, then I'm going to have a 20th. I'm not sure how I know, to be honest with you.
Okay. You've just done it so many times. It's just sort of there. Yeah. And so one of the things that we would want for kids, I would submit, is that we would want them to be able to look at 1/4 of a fifth and be able to think about, hey, like I can think about a fifth, that's like 5 pieces. 1/4 of those would give me 20 pieces. Bam. It's 1 out of those 20 pieces.
Yeah.
Now, not that I don't want that to be like a long, laborious. I don't think it is. But we would want them to be able to lean back on that in any case. Like they can
You
really.
know what we don't want? We don't want them to say, multiply the 4 by the 5 and that gets you 20. Like I actually think about a fifth and a fourth of it.
And that gets you the 1/20th. You actually think about it.
Yeah.
Nice. Cool. So if I were to ask you actually, let me do one other quick thing before I ask you that. If there is a different way that we could visualize the 1/4 times 1/5, and I think this goes back to kind of what the two teachers were looking at me strangely. I could draw a rectangle, and I'm going to go ahead and draw kind of I'll go ahead and draw the same Hershey bar, and I could say that the height of the Hershey bar, let's say I was in the top left-hand corner and I'm an ant on that Hershey bar, and I'm going to walk from the top left-hand corner down to the bottom of the Hershey bar. I could say that I was going to walk the whole height of that candy bar, right?
Okay.
And if I were to start in that same top left-hand corner, I could have walked to the right and walk all the way across the width of that candy bar. Are you good? You're good?
Yep.
Yeah? Yep. So let's say I'm that ant, and I could have said, hey, instead of walking down, starting in that top left-hand corner, instead of walking down that candy bar, I'm only going to walk down 1/4 of the height of the candy bar, and I'm going to stop. So I'm just going to walk that length. Could you like what would you do to show where the ant had sort of walked, to like kind of stop there?
Yeah. So I'm starting in the top left corner, and instead of going the whole length, the whole unit, I stopped a fourth of the way down, and I put my ant there.
You put your ant there. And so so if I were going to represent that on the board in front of the class, I might actually say, like, how do I know where this is? And the kids might say, well, you could, cut it in half and then cut that half into half. And so I've actually drawn kind of where I've cut the whole candy bar horizontally in half, and then I've cut that half in half, and then I've cut the bottom half in half. So you can kind of see fourths, but the ant really has just crawled down to that sort of spot. And then I could say, like, if that was kind of how I was describing that dimension of the candy bar, that's kind of 1/4 of the height of that candy bar. And I could kind of label that distance the ant has walked as 1/4. Does that track? Okay.
Yep.
If I was that same ant up in the upper left-hand corner and I was walking across the candy bar to the right, this time I only want to walk 1/5 across the candy bar. And so then I would say, like, how could I find that fifth? And then the kids are like, well, divide that into fifths. And so then that's kind of hard to do, but I would sort of eyeball dividing that into fifths. And I went ahead and kind of drew vertical lines where the fifths are all the way across. But if that ant was walking, it would only walk like a fifth of the way. And so then I've kind of labeled that over to that first fifth where I've kind of labeled that 1/5. Does that track?
Yep.
Okay.
Yep.
Can you tell me what your rectangle looks like now?
I actually didn't put all the cut lines.
Okay.
But I can picture what you did. So if the ant started in the top left corner and was walking horizontally, it only went a fifth of the way of that whole unit, the whole length. So do you want to know what I have left on my paper? Like I kind of have.
Yeah.
Go ahead.
Well, no. Tell me what your whole thing looks like.
So I have this giant rectangle, but I am only focused on this tiny corner here where the ant walked down a fourth of the unit and across a fifth of the unit. So I'm kind of left with this little, it's not quite a square, but there's this area here in the left corner.
That's like a fourth of the height by a fifth of the width. And it's this kind of rectangle right there.
Yep.
Cool. Excellent. And I would want students to be able to picture that as well, which I think is kind of what the teachers were going for when they were like, why are you cutting the fifth vertically into fourths? They thought I was going to cut the whole rectangle horizontally into fourths and then end up with sort of this double shaded thing. When I say sort of this double shaded thing, the reason I say that is because I think a lot of teachers out there, as we've tried to bring meaning to multiplication and multiplication fraction specifically, is they've taken a multiplication problem like a fourth of a fifth, and they've cut the rectangle into fourths, and they've drawn the 3 lines to cut it into fourths horizontally, and then they've cut it into fifths vertically, and they've drawn the 5 lines to cut it into fifths vertically, and then they shaded one out of the 4 fourths, and they've shaded one out of the 5 fifths. And where they double shaded, then that was like their answer, and then they would sort of read off the answer. They'd be like, okay, the double shaded part is how I've got one double shaded here. And so 1, and then they would count the total number of things, and they would say it's 1 out of those 20 total things. So teachers, I would invite you to consider, if you have taught this as a series of things to do, here's the rectangle, cut it into these pieces, cut it into those pieces, shade this, shade that, count the double shaded, count the total. Then what you've done is you've turned reasoning about fractions into a procedure to mimic and count. And if you go back to the development of mathematical reasoning graphic, counting strategies is that least sophisticated of all of the kinds of reasonings that we're trying to develop. And so, yeah, kids can do it, but we've sort of stuck them down into counting strategies because they just draw the lines, shade, count. So I'm trying to lean away from that procedural counting strategy and instead really asking, hey, if the ant walked, where would this 1/4 be? If the ant walked that way, where would the 1/5 be? Cool. And then what would it look like to talk about the area of 1/4 of the candy bar by 1/5 of the candy bar? And, oh, well, it would be this little guy here. And then we would also have to talk about, how can you tell how many other pieces there are? And it might even make sense to not draw all the cuts, because now at this point, you've just got that little rectangle you were focused on in the upper left-hand corner. And now they have to visualize what else. Now I'll go ahead and let them draw them in there, but I want them to really be thinking about that. They kind of have a 4x5 rectangle. If they've cut it into fourths and they've cut it into fifths, so how many total pieces are there? And I want them to think about that in a multiplicative way, not just counting the total number or just doing what I tell. Just multiply those and you'll have the total number. Does that make sense?
Yeah. And it might be hard for some of our listeners to hear, because for the first time ever, they might think, oh my gosh, my kids totally made sense of multiplying fractions by fractions because now they have a visual.
They were using the model, and that's what we're supposed to do. We're supposed to use manipulatives or models, and they've got it. We've done the CRA thing, and so magic has happened. When in reality, they were actually just like mimicking and counting.
Yeah.
So we'll just invite you to consider, everybody, that maybe a first thing to do would be to think about cutting that candy bar just vertically and really focus on what's actually happening and helping the kids reunitize and giving them some space to have their brains strengthen with all of those different levels of units that they're coordinating, so that their brain can actually strengthen to do that kind of work before you even move on.
And hey, so you did not intend to go into this 8th grade class and spend I don't know how long you spent, but I'm assuming you didn't spend, a little bit of time on a fourth of a fifth.
Yeah. Well, so that conversation about 1/4 times 1/5 took the entire time we were supposed to do a whole problem string.
Yeah.
And so that's about as far as we got. Yeah. So Kim, we're totally over on this podcast. So I would just ask, we're not going to do it, but this is where I would finish. Could you think of, so listeners, 1/3 times 1/4 in both ways? Could you actually think about 1/3 of a fourth by splitting that candy bar up and then splitting the piece up? Could you think about it using area, but not in a rote memorizing, mimicking, counting way, but in like, where's the ant crawling? And so what does that piece look like? And then out of total, how many pieces would that area be of something like 1/3 times 1/4? And then could you generalize, if that's true, then what is, if I gave you a fraction that was 1/8, now I'm going to use a positional description because just so we're all 1 divided by A, 1 over A, that fraction 1/8 times 1/b, so 1 divided by B or 1 over B. If I have 1 divided by some number times 1 divided by another number, could we generalize what that resulting fraction will be? And I don't know, Kim, do you have some words for how you would generalize what that?
Yeah, but I want to say that again, because when you said 1/8, I thought you were saying the number 8. So 1 divided by A times 1 divided by B.
Correct. Yeah. Okay. Letters. I'm trying to be general. 1 divided by X times 1 divided by Y. I'm trying to be general. Yeah.
You want me to say what I think that is?
Yeah. What might, I mean, I could tell you what I'm hoping for, but what would you hope, like, or maybe you just tell us if I say that 1 divided by A times 1 divided by B, what do you think? Because here's what I think you don't do. I don't think you go, which rule is that?
No.
What do you do?
So in the context of your ant, I'm thinking that the A is one dimension that it's walking and B is the other dimension. So it's going to be 1 divided by A times B.
Okay. I'm sure you've got like more happening in your head to make that happen, but you've got 1 divided, like sort of dimension of 1 divided by a dimension of 1 divided by B, and the area
Yeah,
of
so
that. Go ahead.
the 2 dimensions tell me how many of the total pieces that are in it's one of the total number of pieces that it could have covered.
Ah, okay. And so you're sort of thinking about an A by B rectangle.
Mm-hmm.
And so you're like, bam, then I know it's A times B is the total number of pieces.
Yeah.
Just like 4 times 5 was the total number of pieces, or if we had
Uh-huh.
done a third by a fourth, then it would have been 3 times 4 would give you the total number of pieces.
Yeah.
So, and then how do you know it's 1 divided by?
Because it only went 1 unit fraction each way. So it's
Mm-hmm.
1 of the total number of pieces.
Yeah, when that ant crawled down and then crawled over, it only went, and it was 1 of those total number of pieces. So a generalization I would want kids to come up with is, if I've got a unit fraction, and we're saying a unit fraction, which means the numerator is 1. If I've got a unit fraction times another unit fraction, then I can really think about, well, that's going to create a total number of pieces that is that A times that B. That's the total number of pieces, but I only want 1 of them. So 1 out of the A times B pieces, 1 divided by A times B. That's a generalization actually I want to make with understanding that kids are really thinking and reasoning about that. And then in our next episode, we'll build on that. So I think a lot of teachers are like, hey, multiplication of fractions, multiply straight across. Bam, we got it. Boom. The only other thing you do with it is the cross cancel thing, or whatever you want to call that. I don't like that verbiage, but where you sort of are dividing out common factors. Those are usually, when I see a typical fraction instruction in textbooks, that those are usually the 2 things that happen with fraction multiplication. I'm actually suggesting we need to start with a unit fraction times a unit fraction, and we're going to build from there. You can't wait to hear next week, eh?
Yeah.
All right, y'all. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable. Y'all, Kim and I get so many questions. So many of you are encouraged and excited to teach math, real mathing, and we're doing our best to answer your questions in depth, but we can only do so much on the podcast. But there's so much more.
Where can you learn all the things that you need to make math more figureoutable? In our Building Powerful Mathematics online workshops. Find your best fit at mathisfigureoutable.com/workshops.
If you are a pre-K through 12 educator, we have a workshop for you. Here's a bit of a breakdown. If you are pre-K 2, check out Building Addition for Young Learners. Grades 2 and up, Building Powerful Subtraction. Grades 3 and up, Building Powerful Multiplication. Grades 4 and up, Building Powerful Division. Grades 5 and up, Building Powerful Proportional Reasoning. Grades 8 and up, Building Powerful Linear Functions. And our most recent, for everyone, Building Powerful Fractions 1.
You can find the best workshop for you and register at mathisfigureoutable.com/workshops.
Let's change the world together and make math more and more figureoutable.